Hi, I'm Brian Holt. I'm a product manager at Neon, and this is the complete intro to SQLite. I created this course because SQLite is an extremely battle-tested piece of software that will help you create better apps. In this course, we'll cover what's unique about SQLite that makes it perfect for embedded apps, recent innovations like streaming backups, replication, and even cloud deployments that make SQLite well-suited for the future. Learn SQLite and see how portable and flexible your data can be. I have artist, album, and track, right? I have all the tracks that are in the various different albums. I have all the albums and all the artists that made all of these albums. Now you could basically go in and say, here's this track from, Led Zeppelin album, right? And it has the artist Led Zeppelin, and it has the album of 4, and it has the track of Black Dog or something like that, right? The problem is like, what happens if Led Zeppelin changes their name? Like, what if they're Prince and they become the artist formerly known as Prince? You have to now go and update every row in your database and hopefully find all of them, right? Particularly if they have a weird symbol for a name now, which has never happened. Very appropriate to talk about this in Minnesota, right? Difficult, right? And anyone that's done any amount of trying to keep two things in sync knows that everything always falls out of sync. That's just the facts of life when it comes to computer science. So it's a bad idea. Artists rename themselves, albums get changed, tracks get added, they get subtracted, and trying to keep all that stuff in sync would be a nightmare to try and maintain. That's why we have multiple tables. We have artists, we have albums, and we have track, and they're all separate from each other, but they all relate to each other using relational data. That's kind of the point of a relational database, if we're being super honest. So let's talk about one-to-one relationships. One album has one track, or one track belongs to one album, assuming you're modeling it that way, right? So you don't have a track belonging to multiple albums. It's just, a track on an album. Another example of that would be members of a band, right? So you have someone like Dave Grohl that's been in a bunch of bands, right? But he's, has that like one-to-one relationship for them. Or, many to one, one to many, something like that. So I think this gets more concrete once we start running the queries here. So I say select star from album, and I'm just going to limit it to 5 because I don't want to see a bunch. And let's just do schema of album. So it has an album ID, it has a title, which you see these, right? These are all, as you probably know, these are AC/DC songs. You have an artist ID, right, so you have this artist ID that corresponds to what artist wrote this, and you have a album ID, which corresponds to like which album this is, right? As you probably guess, if you go into track, they have a track ID, an album ID, right? But notice that there is no artist ID on this. Why? Because the artist ID is on the album, so that belongs at the album level. You don't repeat it into the track level because they all kind of, correspond to each other in kind of a chain, right? Now we're going to talk about joins. We're going to say select artist.name and album.title from album join artist on, and you're just going to tell it what two things correspond to each other. How can I tell that this artist and this album meet up together? They're going to have some sort of mutual ID typically, which they do. We're going to say album.artistID equals artist.artistID. Artist. Okay, and I'm just going to put limit 5 there again. And now we get AC/DC, except AC/DC, Aerosmith, all that kind of stuff, right? So we took the information that was in this album table and we joined it together with the one that was in the artist table to get one result set based on both of those. Views are not unique to SQLite, but they certainly have their own kind of spin on them. So this query right here, this is just joining track to album to artist. So if you run this, where is my database? Oh, I need to get rid of that. Get status. I'm just going to, oh, no, that's fine. Okay. Data.db, and I run this query. You can see I'm just getting ID, name, title, and name, and I'm doing it with 2 different joins, and I'm getting all of the artists, the album names, and the tracks, right? Nothing too interesting here. Now imagine like I'm Spotify, and every time that someone goes anywhere in the Spotify UI, you have to show them all 3 pieces of information about any music that they're looking at because they want to see all of it, right? Can you imagine having to do this join any time that you want to do that? It's like on every page, right? It would be a pain in the butt to do it that way. It would be nice if they're all on the same table, but they're not. And they can't be because of the reasons we've all just talked about. This is what a view is for. A view is basically saying like, it's like a layer on top. It's like an abstraction away from a table where you can say like, I'm going to present something to you that looks like a table, but underneath the hood, it's going to be querying other tables underneath it. It's a view into other tables. So basically you're going to construct a query that's going to define a view. And then from there, you can query that set of data as if it was a table, which is kind of cool, right? You can call this whatever you want. I'm going to call mine create view easy tracks as. So here you're just going to write your query. T.track ID as ID. AR.name as artist. AL.title as album. And T.name as track. From track T. Oops. Oh, that might be a problem. It will be. Let's try that again. So shell.clear, we'll start again. Create view, easy tracks as, and then here you're just going to write your query as if it was a normal SQLite query. T.track ID as ID, AR.name as artist, AL.title as album, T.name as track, from track T, join album AL on T.album ID equals AL.album ID, and join artist AR on AR.artist ID equals AL.artist ID. Okay. Pretty simple. It's just create view as, and then you just give it the query that defines the view. Okay, now I just say select star from easy tracks, limit 10. And now that is a way easier query to wrangle, right? Pretty cool. I think it's pretty cool. It can make your job a lot easier. So assuming that you've got both of those downloaded and installed, let's go ahead and run our container here. SQLite will not run that. Surprise, surprise. Cool. Docker run. This is going to run a new container. You're telling it to expose port 9000 on port 9000 and 9001 and 9001. You're telling it what container to get, which is the Minio container from the Minio organization. And then this is everything that you're passing into run Minio. I never use Minio directly. I just literally go and copy and paste this. I should have it already running. Okay, you can ignore all this stuff. I don't think it matters. And I think you can just go straight to this URL. Yeah, you should end up on something like this. This is just running locally on my computer. Great. And now that we've done that, we're going to log in, and we're going to call it's Minio admin for both username and password by default. My official security recommendation is always use the default username and password. No, I'm just kidding. That's a terrible idea, but it's fine for our local testing purposes. We are now in here. We're going to click create a bucket. What did I call mine? I called mine Chinook backup. Okay, I don't think you need to do anything like that. You just create bucket. We're going to click into it and make sure that it is on public. Cool. That's it. That is all the Minio stuff that one must accomplish. We are now on that. This looks like it's running Docker, so I'm just going to open a new tab here. Okay. Now what we're going to do is I'm going to go copy and paste these two things from my notes, which is these two. This is just the username and password that it's going to use, and I'm going to make them environmental variables. If you're not familiar with Bash, this is just making it so I can reference Litestream access key and access ID from the environment, right? If I close this terminal, and it's going to throw away all the temporary variables as well. So this is only going to be working for this session of the terminal that I have up here. Okay, I've done that. Now I just have to go run the Litestream command. So I have Litestream installed, I think. Cool, I do. So what I'm going to say is Litestream replicate data.db, which is the one that I have here, right? So /datadb, the one that we've been using this whole time. It's going to be an S3 protocol. That's, like I said, you can read and write to Minio as if it was S3. I'm going to do Chinook-backup, or whatever you chose to call it, .localhost :9000 /data.db. And now, if I start reading and writing to that database, it's all going to be streamed into that Minio bucket that I have. So I think if I go to Object Browser, Chinook Backup, you'll start seeing the I don't know how this is structured at all, but you'll see that there's snapshots and a bunch of stuff like that are all being now streamed to this Minio bucket. As you might imagine, we just did S3. Where is it? Yeah, this one right here. We did localhost here, but there's nothing stopping you from just doing this directly to S3, like on Amazon or on, cloud-hosted Minio or GCP or Azure Blob Storage or any number of the object storage kind of places. And it's really just this easy. So what you would do with your particular blog, if this is what you're doing, you would deploy to your DigitalOcean container, your Vercel, or whatever, wherever you're deploying it. You would start your server, and then you would start the Litestream replicating somewhere else, and then you're good. You're golden. You are now streaming this somewhere else. You can feel safe that this is now backed up and working just fine.